There's a kind of civil war brewing right at the heart of artificial intelligence. Billions, literally billions, are being poured into making chatbots bigger and bigger. But one of the founding fathers of the entire field, he's sounding the alarm, basically saying the whole industry is charging full speed down a dead-end street. So what's really going on here? Let's break it down.
And yeah, he is not mincing words. That's Yann LeCun, Meta's chief AI scientist, and that statement, it's a direct challenge to the dominant strategy at companies from OpenAI all the way to Google. So who is he? And why does his opinion carry so much weight?
Well, for starters, LeCun is one of the three godfathers of AI. He's a winner of the Turing Prize, which, if you don't know, is basically the Nobel Prize of computing. We're talking about a true pioneer here. From his early work recognizing handwriting for banks, all the way to being handpicked by Mark Zuckerberg to build Meta's AI lab from scratch, his fingerprints are all over the AI we use every single day.
And that's what makes his position so startling, right? He believes that the entire industry's all-in bet on large language models, the tech behind ChatGPT, is fundamentally flawed. He calls it a dead end. So that brings up a huge question. What does a founder of the field see that the rest of the industry is apparently missing?
All right, to really understand where he's coming from, we need to dig into the core of his argument, which is all about the deep, fundamental limits of building an intelligence entirely out of words. So let's really get into it. Why does he think this multi-billion-dollar path is just destined to fail?
Okay, so it all boils down to this: a massive inefficiency. Think about it. Today's models, they learn by just predicting the next word in a sentence. But to do that, they have to model everything, including all the little details that are totally unpredictable and, honestly, irrelevant. He's got a great analogy for this. It's like trying to predict the exact shimmer of light on a leaf blowing in the wind. It's just noise, and it wastes an unbelievable amount of computational energy. And this leads to some really big flaws. He argues they're less like inventive minds and more like gigantic, fancy memory banks. And that whole word-by-word generation thing, it's painfully slow for anything that needs to happen in real time, like, say, robotics. They burn so much energy just learning the difference between the light is off and the room is dark, which to us is the exact same idea. But here's the real kicker. They have absolutely no real grasp of how the physical world works. None.
Okay, so if that's the dead end, then what's the right path? Well, LeCun's vision isn't just a tiny course correction. No, it's a completely different destination. He calls it a world model.
And the core idea here is actually pretty intuitive. Instead of spoon-feeding an AI mountains of text, you let it learn like a human baby. I mean, think about it. A baby learns about gravity by dropping its spoon over and over, right? Not by reading a physics textbook. World models do the exact same thing. They just observe the world, mostly through video, and build their own intuitive understanding of the rules.
And the specific technology he and his team at Meta have built to make this happen is called JEPA. It stands for Joint Embedding Predictive Architecture.
And this right here is the fundamental shift. It's a total change in philosophy. Instead of predicting the next word or token, JEPA learns to predict the abstract meaning of what comes next. See the difference? We're moving the goalpost from just language to actual understanding.
So how does it actually work? It's pretty clever. The model gets shown a piece of a video. Then, you just hide a big chunk of it. You mask it out. Now, the model's job isn't to perfectly repaint all the missing pixels. That would be that old noisy problem again. Instead, its job is to predict the high-level abstract idea of what's in that missing piece. And what this does is, it forces the model to ignore all the noisy, random details and focus only on what really matters: the underlying structure, the physics, the logic of the world.
Okay, so that's the theory, and you got to admit, it's pretty elegant. But does it actually work in the real world? Well, the proof, as they say, is in the pudding, or in this case, the performance. So the researchers set up a direct apples-to-apples comparison. It's a classic token-based model versus a JEPA model. And guess what? The JEPA version, even with about half the parameters, started learning faster and got better results. And that's not just some clever tuning trick, that's a fundamental structural advantage. And this new approach really shines when you give it video. Because it operates in this abstract meaning space, it can chew through long videos needing almost 3 times fewer of those really expensive decoding operations. It basically only bothers to generate a description when the actual meaning of the scene changes. So efficient.
But the ultimate test, the really dramatic one, came when they hooked this AI up to a real-world robot and told it to plan its actions in real time.
And the difference here is just staggering.
I mean, look at this. A traditional model, one that tries to predict the future pixel by pixel, took 4 minutes. 4 minutes to plan a single action. The JEPA model, planning in its abstract meaning space, took just 16 seconds.
Yeah, that is a 15 times speed up. 15. That's the difference between a slow-motion lab experiment and a robot that can actually function in the real world. This is the payoff. This is what you get when you stop focusing on the noise and start focusing on the signal.
Okay, so these results are obviously impressive, but what does it all mean for the bigger picture? Let's zoom out a bit and talk about the future of intelligence itself and, this massive hype cycle we're all caught up in.
LeCun is basically warning that history could repeat itself. He points back to the 1980s when there was this huge wave of hype around something called expert systems, and eventually it all came crashing down, leading to what we call an AI winter, a period where funding and interest just dried up. He's worried that by going all in on this one single flawed approach, we could be setting ourselves up for a similar backlash when the tech inevitably fails to deliver on all the hype.
And why? Because as he argues, today's systems are still missing the key ingredients for what we'd call true intelligence. They still can't really understand the physical world. They don't have any kind of persistent memory. They can't reason very well. And they can't plan complex actions. And these, he says, are the hurdles that just making LLMs bigger and bigger will never, ever clear.
And that really brings us to the core takeaway here. For Yann LeCun, the real path forward, the path to truly capable AI, isn't just about throwing more data at bigger models. Nope, it's about a fundamental revolution in how they're built, in their architecture. It's about building them from the ground up to understand the world, not just to get really good at mimicking human text.
So this leaves us with a huge, critical question, right? As we build this next generation of intelligence, where are we going to focus our energy? Are we going to try and build systems that learn to truly understand the dynamics of our world, or are we going to settle for systems that are just getting better and better at predicting our words? How we answer that question is probably going to define the entire next decade of technology.